Good morning and once again welcome to my YouTube channel Maths with Ease by Mr. Kamotho. In this video we are following the slide number 9, which is telling us prove using completing the square. And in example 8 we are supposed to prove that x squared minus 8x plus 16 is greater than or equals to 0 for any value of x. Hence, sketch the graph of y is equals to x squared minus 8x plus 16. This is what we are supposed to prove for all values of x by the use of completing the square. By the use of completing the what? Completing the square. By the use of completing the square. It goes without saying now, x squared minus 8x plus 16 is the one we are saying is greater than or equals to 0. Assuming this one is, let's see what happens. The coefficient of x squared is 1, so we don't need to do anything as far as that part is concerned, because one thing and one condition that we must remember, when we complete the square, the coefficient of x squared has to be 1, because completing the square method is when we have x plus b squared is b, when we have x squared plus bx plus c. This part is the one which is responsible for the completing of the square. So we have x plus b over 2 squared minus b over 2 squared plus c. We have now completed the square. And what we are having here is x. Our b is minus 4, so minus 8 rather. So minus 8 over 2 is minus 4 squared, b over 2, minus 8 over 2 minus 4 squared, now plus c, plus 16. This one is just going to be greater than or equals to 0, because that is the original statement. Of course, we know x minus 4 squared minus 16, because this is 16, plus 16 is greater than or equals to 0. It goes without saying that minus 16 plus 16 is 0, so we are left with x minus 4 squared is greater than or equals to 0. That is what we have. Graphically, we may want to actually just show this graphically by coming up with a graph, so to speak, by coming up with a graph that may represent this information, just sketching, whereby we have minus 1, minus 2, minus 3, minus 4, and we have 1, 2, 3, 4. We may have 2, 4, 6, 8, 10, 12, 14, 16, and 18. This could be 18. This is 16. This is 14. This is 12. This is 10. This is 8. This is 6. This is 4. And this is 2. I don't think we need the negative side, because our function is already greater than or equals to 0. And it goes without saying, when we have this, note that when x is equals to, let's say, 4, of course, when we have anything squared, there is no way we can square a number and then we have a negative answer. No, it's not going to be that way. So when x is minus 4, so to speak, minus 4 minus 4 minus 4 minus 4, we are going to have minus 8 squared is 64. When x is 0, 0 minus 4 is minus 4, and minus 4 squared is 16 itself. That is the point we are talking about. When x is 4, 4 minus 4 is 0, and that is exactly the point we are talking about. If you continue now to have the same kind of graph plotted, you would say, let's say 5 minus 4, and then when x is 5, let's put 5 there. Minus 4, we have 1. 1 squared is equals to 1. And then our graph starts rising. So the construction of the graph is easily that way. And you can see from the graph, there are no negative values of y, and that simply proves our statement, prove that x squared minus 8x plus 16 greater than or equals to 0. You can see from the solutions of the graph that the least value of y is 0, and y is always greater than 0, but at some point it is equals to 0. So this statement is valid. The graph explains that, and therefore our equation is already verified, and we have been able to construct that graph. That is exactly what we were to show and to prove. Thank you. Follow me, subscribe, and share widely so that we can work together. Let us meet in the next video.